All right, so on to this week's lesson. Today we're going to be going over material strength, which is something that's so incredibly important in engineering and engineering sciences. Um, and yeah, I think you guys will find to like this unit specifically. So first off, why materials matter. So I want you guys to look around you. You know, everything you see is made of materials someone had to choose. Engineers and designers think really hard about what materials to use because different materials behave in different ways. So some are strong, some are flexible, some are cheap, and some are expensive. And for example, think about why like we don't build bridges out of something like glass. Glass can break very easily under pressure. So just imagine like trying to build a skyscraper with plastic straws, you know? It wouldn't work. You have to pick materials using your best judgment and their physical qualities. So materials like steel, concrete, and some woods are chosen because they can hold heavy weight and survive tough weather conditions. This is why materials matter. If you pick the wrong one, things can break, collapses happen, and in community or commercial structures, this can be dangerous, or typically is dangerous if your whole building is collapsing. So, can anyone tell me a material they think is really strong or one they think breaks really easily? You guys don't have to raise your hand or anything. You guys can just talk out loud.
Something strong is steel. Can you repeat the
Yeah,
question?
still very simple. Um, can anyone name a material they think is really strong or one they think breaks easily? Did you have one in mind?
Like plastic?
Yeah, plastic breaks super easily. Well, I guess, yeah, if it's not compact, when you think of like plastic water bottles, those are incredibly easy to crush. Um, yeah, so moving on, what makes materials strong? So materials need to be strong enough for the job that they do. Some materials resist force really well. That's called strength. Others bend without breaking. That's flexibility. Think of tires. Tires aren't too incredibly difficult to pop, right? If you just stick something sharp in them, they'll lose all the air they have inside. But because they're flexible, even as they're rolling at 60 miles per hour on the highway, they're able to kind of form into whatever shape we need them to, right? That's why we're using something like rubber with air in it. Even if it's not the strongest material, we're using it for such a heavy duty job because it works well for this. And some materials last a really long time. That's durability. Think of concrete. Concrete's strong as well. It's not, I don't think it's stronger than steel, but what's more important as to why we use it is because it's so durable and because it lasts such a long time, especially against heavy weather conditions like rain. So when engineers choose materials, they think about what the structure needs to do: hold weight, survive weather, or stay flexible. So how engineers test materials. Before building something big, engineers test materials in different ways. They pull on them to see how much they can stretch, called tension. They squeeze them to see how much they compression, and they bend them to see if they'll break. Testing tells us how a material will behave in real life. And engineers can't just guess. They can't eeny, meeny, miny, mo, right? It's an experimental process, especially in civil engineering when you're building commercial structures, right? Ones with a lot of people going into them. This has to, you have to put so much consideration because it holds a lot of responsibility. People's lives are at stake. Um, so for example, up here, you can see a bridge or a model of a bridge being tested, right? And then we use those ratios and we kind of make them a lot bigger if this passes this test. But this is just one of the ways that we would test something like a bridge. Or for example, down here, this is actually an earthquake simulation, which is especially used in places where earthquakes are a lot more common, I know most of us live in Texas, but in a place like Japan, where earthquakes are super common, structures usually have to pass this simulation, right? So this basically shakes your structure rapidly and sees how strong it is resisting a fall, right? So if we're building something that's meant to resist something as big as an earthquake, it needs to be strong. The materials need to be strong enough to not break, but the overall structure still needs to be flexible. Think about it. If you shake something really quickly, or say you have something on your desk and you shake your desk really quickly, it might just tip over. But maybe you have like something like jello on your desk and you're shaking your desk a lot and it's not tipping over, right? It's kind of flowing with the way that you're shaking it. The overall structure of a building kind of needs to be like that for specific natural disasters. So you have to consider these things. I feel like for Texas, we would more so be considering floods, saying how durable materials are against water pressure. Um, yeah. So these are things that you really need to consider when you're thinking about materials and building things. Really quickly though, I want to go into, oh, it looks like this photo isn't showing up, but I do want to go into some famous structures and failures because engineers are constantly learning about mistakes. So one famous example of a failure is the Tacoma Narrows Bridge. So this bridge basically collapsed because it wasn't strong enough to hold wind. It wasn't strong enough to resist that. And you can kind of understand that. I mean, this is incredibly narrow. It's not heavy enough to resist the force of wind, right? Have any of you guys ever heard of something called inertia or inertial mass? You can say no if you haven't. Again, anyone can just speak out.
Yeah,
You've heard of it?
yeah.
Yeah, perfect. Well, inertia, for those of you who haven't heard of it, is basically the resistance to a force. And usually you'll think of inertia as mass. This might change when you're talking about rolling structures or something, but it's the resistance to force. And the heavier something is, the more inertia it has, right? It has more of a resistance to force. This is incredibly narrow. It wasn't heavy enough to resist the force of the wind. And engineers learned a lot from that mistake. Today's bridges use better shapes, strong materials to stay safe. Think about how different modern day bridges look. Um, they're designed to resist these forces much better. Engineers today build with lessons from their past so that make so they make sure that their structures stay standing. So I want you guys to analyze this. Say you need to build a bridge and you can choose between paper, steel, or rubber. Which would you pick and why? Think about what's strong and flexible, or think about what's strong, what's flexible, and what can hold weight. Again, anyone can give me an answer on this.
Um, I would pick the steel for a bridge because it's not bendable, at least not easily, and I think it would be more durable.
Yeah, incredibly durable. That's an amazing answer. The steel would resist breaking or more under pressure, under the weight of your body if you're planning to walk on this bridge. Earlier, I did reference the fact that we wouldn't use glass to make a bridge, right? So now what if I told you you weren't building a bridge? You're building something else, like engineers do. But what if instead I told you your sibling was annoying you and you wanted to build a slingshot to annoy them? Now what material would you use?
Rubber.
Yeah, rubber. Perfect. It's stretchy, so you can Fling whatever you want with them. Sorry, I'm not trying to encourage you guys to hurt your siblings, but this is just more so to tell you guys it's all about context and what your structure, not structure, but whatever you're building, what you want it to do, you have to make sure you're using materials that behave in the appropriate way. And I want to touch up on shapes as well. So a lot of people have wondered why so many bridges use triangles in their designs. So triangles spread out force evenly and keep structures stable. If you build it with squares, you can see here it would start to kind of lean. I don't know if you guys have ever built a paper bridge, but if you try to make one, maybe not paper, well, I'll say index cards. There's a reason we make the tower, not index cards, the playing cards. Have you guys ever seen when they make like a huge pyramid with playing cards? There's a reason they're in triangles because if you made them in squares, they definitely fall a lot easier. It's also a lot harder to balance. Um,
I have a question.
yes, sir. What's your question?
Sorry for interrupting, but I don't know if you kind of said it, but didn't they choose that because triangles are the strongest shape?
Yeah, triangles are the strongest shape. They resist force the best. Um, especially when it's put on top of them. That makes sense. If you guys have playing cards around, you can kind of test this out. Or just like index cards, you could tape four index cards together and then try to put something on top of the square, and it's gonna fall over. But maybe you can try a triangle, try to balance something on the tip, and it's not gonna fall directly into itself. That's just not what would happen. Um, unless you're using something like super heavy. But yeah, they're the strongest shape out there. Usually this is the most common example of a bridge I've seen with triangles. Usually we'll see this shape. I think this is called a truss. There are some arch shapes. Arch is also a very strong shape, but we typically rely most on triangles. So I want to give you guys a quick activity. I'm gonna give you guys a few minutes to look around your house. I'll give you about 8 minutes. So you guys can look around your house, find something strong. It doesn't have to be like a huge structure. Just find something strong. It could be something like where your cabinets are sitting, I guess. And when you come back, I'd like you guys to explain what you believe makes it strong or sturdy. So I'm going to give you guys a few minutes and I'll leave this up for you guys to reference back to these instructions. But I'll remind you all when your time is up and you guys can come back to talk about it. Oh, your time starts now. I'm not sure how much time you guys need, so I'll make this easier for everyone. Once you guys have your structure or whatever you have in your house in mind, you guys can use the raising your hand icon on Zoom.
I'm done.
You guys are done. Can you guys share what you found?
Well, it's like a statue. It's made out of metal, but like, yeah, copper metal, and it's very stable.
Oh, have you tried tipping it over before?
Tipping it over. I can try it right now. Hopefully it doesn't break.
Oh, you don't. I don't want to get you guys in trouble. I was just wondering
This
how
glass.
strong it was.
I'm not gonna do that first. Okay. Wait, how much weight? Like tipping over slightly. If I tip it over, actually no, it's gonna break. But if I tip over slightly, it'll fall over. Like if I turn it, like it has a like flat bottom, but if I turn it on its side, it's gonna fall over.
I mean, that sounds pretty, especially because the material that sounds sturdy. Do you guys think if you put it on like two tables, it would be able to hold something like a bridge?
Yeah. Should we show you?
You guys can show me?
Yeah.
Yeah, let me see. Oh, that's huge.
Yeah.
Yeah, that's very sturdy. What did everyone else find?
Um. Can I go? Can I go next?
Yeah, you can go.
What I found isn't as huge, but I have like an old basketball medal, and
Mhm.
I can't tell what the material is because I think it's like painted gold or something because I know it's not real gold. But I mean, I noticed that's very sturdy.
Yeah, does it feel like metal or what would
Yeah,
you say it feels
it's
like?
definitely a metal.
Perfect. Do you also think that if you put it between two desks, like how much weight would you say it could probably support?
Um, maybe like a cup. Like if I were to balance it well enough, I think I could put like kind of use it like a coaster, but like in between so it would balance.
A coaster. Oh, very interesting. Sounds sturdy. Can I hear what anyone else found? I think someone else had raised their hand. Sri, did you find anything? I'm not sure if I'm pronouncing that right.
Yeah, I found like my table.
Your table?
Yeah.
Can I ask like how big it is?
Like I guess I mean it's like a standing table or like you can change its height.
Oh, cool. I think I've heard of those before. Yeah, so you guys seem to have found some pretty sturdy things. Um, Now I'm gonna move on to y'all's homework, which is kind of similar, except this time I want you guys to basically find a structure. So that one was more of something like an object in your house. But I want you guys to find a structure. It could be like in your house, it could be at the park, it could be like a bridge in the neighborhood. It could be anything. But explain what makes it strong, maybe what materials it's made of, that you can tell it's made of, and what kind of shapes it holds.